right, so scientific notation we talked about is a specific format of how to write numbers that can take really, really big numbers and really, really small numbers and make them look a little bit simpler. And you guys will use this in science this year, I promise, okay? Last year I thought they used it before we taught it, but this year apparently y'all haven't seen this yet. So right here we have a really, 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 really big number. Can y'all count how many zeros are back here?
No.
21 zeros. That's a lot of zeros. Imagine if you had to type or write this number a lot of times. Don't you think at some point you might lose a zero? Yeah, and so that's why we have scientific notation. Same with this number. Y'all, there's not even commas here. When there's not commas, I really can't keep up with it, okay? And so again, this is where scientific notation comes in handy. These numbers, the really big and the really small, these are called standard notation. It's how we normally write numbers. Standard notation is our normal way of writing numbers. Scientific notation is when we have that times 10 and an exponent. Times 10 and an exponent. So this number right here would be 6.02 times 10 to the 23rd power. So y'all told me there were 21 zeros, but we'd also have to move the decimal in front of this 2 and then this other 0. So that would be where that 23 came from. Okay, this really small one, okay, y'all, like I said, there's so many zeros there, I would miscount, but it would be to the negative 15th power. Notice the decimal went behind the 7, the first number that is not 0, and it moved 15 spaces, okay? Now, here's my trick. If you have a really, really, really big number, slash just a big number in general, it's going to have a positive exponent. If you have a small number, meaning it's less than 1, it's going to have a negative exponent. This is the easiest way, just in my opinion, to remember, and this is the way that I use, okay? Positive exponent for big numbers, negative exponents for small numbers. And if we write it in the format times 10 to an exponent, times 10 to an exponent, what do we call this again? What notation? Scientific notation. Okay, so scientific notation. So to change a number in regular or standard notation into scientific notation, all we have to do is move the what? The decimal. We're moving the decimal. Did you just say variable? Are there variables anywhere in here? The decimals left or right. Okay, so if we move our decimal to the left, because it's a big number, it's going to be a positive exponent. Positive exponent. Okay, so we move our decimal to the left when it's a big number and it's a positive exponent. If we move our decimal to the right, it's a small number, which will give us a negative exponent. Okay, and as we practice more, that's going to make more sense. Okay, so guys, think about to what we talked about with our negative exponents. If we have a negative exponent, so let's say we have 10 to the negative 4th, okay, just 10 to the negative 4th. How can I rewrite this as a positive exponent? 1 over, good, 10 to the 4th. And what's 10 to the 4th going to give us?
10,000.
Careful. It's going to be 1 over 1 with 4 zeros. So, yeah, that's 10,000. And, y'all, 1 divided by 10,000, is that a big number or a really small number? A number, 1 divided by a big number. That's going to be a really small number. So that's why our negative exponents are for the really small numbers, because that means they're going to the bottom underneath 1. It's going to be 1 divided by that. So it's going to be really, really small. Okay? All right. So right here in this box, all I want us to do is I want to figure out, are these in actual scientific notation or not? Okay? So what we're looking at here is our decimal. Remember, how many numbers should be in front of the decimal? Just 1. Okay? Can that number be 0? No, it needs to be the first number that's not 0. So 8.52, is our decimal in the right spot?
Yes.
Yes. Do we have times 10 and an exponent?
Yes.
So is this incorrect scientific notation? Yes. I'm just going to do a check mark. Are y'all good with that? Okay. 4.9 times 10 to the negative 1. Is that decimal in the right spot?
No.
Why not?
Because it's not.
Is there one number in front of it?
Yes.
Yeah. Yeah, so that's fine. There's only one number in front of it, so that's good. Do we have a times 10?
Yes.
Do we have an exponent? All right, that one's good. Okay, 11.0. Is our decimal in the right spot?
No.
Where should it be?
It's one.
Okay, it should be in between these ones here. Okay, so our decimal is not in the right spot, so this one is not correct scientific notation, so I'm just going to put an X so I know that one's not right. All right, D, is the decimal good?
Yes.
Do we have times 10?
Yes.
Do we have an exponent?
Yes.
So that one's good.
No.
Why not, Trip?
Because it's a 0.
It's a 0 in front. Very good. We don't want a 0 in front. We want a number that's not 0. Right, any question? No, next one. Okay, so this one, the decimal should be behind the 2, and so that one is wrong. And then Reagan, this last one you're saying?
It's not right because it's not in between the 1 and the 8.
Yeah, it should be in between the 1 and the 8. There's 3 numbers in front of it, and we just want 1. Okay, so that one's also incorrect. Dylan? Huh?
There's a 0. There can't be a 0.
There can't be a 0 in front. It has to be a number other than 0. Just one number that's not 0 in front. Okay? Okay. So what I want to do, I want to go on over here. Can we go run over here? Okay. So I want to do a couple of these problems together, and then I'm actually going to go to the bottom of this page and do some, so that way we know how to go back and forth, okay? So the first number, are these like super big at this point or super small? They're kind of normal numbers, right? So these might not be numbers that we would like necessarily need to do scientific notation with, but it's a good number to practice on, okay? So 0.502, okay? 5.02. Very good, Dylan. So 5.02. We do not drop this 0 because it's in between 2 numbers that aren't 0, okay? So our decimal goes behind the first number. What format always comes next? Multiply by 10 times 10. And then how many spaces did we have to move our decimal? If it was here and it went behind the 5, 1 space, so our exponent is 1. And is this number big or small? So our exponent has to be negative. Okay, so remember right here, if we move our decimal to the right, it's going to be a negative exponent. We moved it to the right, so it's a negative. Huh? It was here, and we moved it right there. Yeah. Okay. So on this next one, what are we going to drop all of?
5.0.
We're going to drop all the zeros. What's going to be our only number then? 5. So I have a question. Hang on, I have a question first. If I don't write a decimal here, where is it understood to be?
It's behind it.
Behind that 5. Okay, if I don't write a decimal, it's understood to be behind this 5. Can I put a decimal here? Yes, if you really need to know that there's a decimal there, you can put it. But I know it's right behind this 5, so I don't have to. And then I can do the times 10.
To the 4.
Okay, not necessarily because there's 4 zeros. We got to be careful with that. We move it 1, 2, 3, 4 spaces to get behind that 5. And did we move from the left to the right?
Right.
We moved to the right, so is that going to be positive or negative? Negative. Or again, this number is a small number, so it's going to be a negative exponent. Okay. 3,584. Where's our decimal going to go?
3.58.
Very good. 3.584. Did we actually get to drop any numbers here? No, because what's the only thing we drop? No, what's the only thing we ever drop? Zeros, okay? Zeros. All right? So there were no zeros, so we didn't drop any, but we did need to move our decimal behind the 3. Question or answer? Okay.
I don't understand how you change from
So what we did, the decimal's back here. Okay? Our rule with scientific notation is that we're going to move the decimal behind the first number. Okay? Then we're going to do our times 10. And Reagan, how many spaces did we have to move? 3 spaces, so our exponent is 3. And which direction did we move our decimal this time?
Left.
The left. Or again, this number is big. It's a bigger number than 1, so it's going to be a positive exponent. Okay, good? All right. 10.0.
We're going to have to move it one time.
We're going to have to move it one time.
So it'd be 1 and times 10. And since you only have to do it one time, it will be 1. And since you moved it to the left, it will be positive.
Dylan,
Move it to.
you got this.
No, you're right.
Yes. I think we finally found your topic. We finally found your topic. Very good. All right. So I want to skip down to this one right here. Okay, this one right here. This 28.7 times 10 to the negative 4th power. Is this in scientific notation?
No.
Oh, good job. Why not?
Because
the decimal's not behind the first.
Oh, I love y'all. So good. It's not in the right spot, so it should be 2.87 times 10. Now this is where we get a little tricky.
It would be negative 5.
Okay.
It would be a positive 5.
Hang on. Okay, I hear bad answers and good answers.
No, it actually is.
Okay, so this decimal is here, and we have to move it to the left one.
So that means if
So if we moved it to the left one, that's a positive 1 space. Positive 1 space. This already had negative 4, and we moved it a positive 1 space, so that gives us a negative 3. Do y'all understand why Sydney said negative 3?
He also said negative 3. Dylan said negative 3.
He said negative 5 first, and then I'm pretty sure he said positive 5, and then he said negative 3.
how do you do 40?
Okay? Because it already had an exponent of negative 4, we moved it left 1 space. That's a positive 1. Negative 4 and a positive 1 make a negative 3. Okay? Right? So what I want to do, guys, okay, we're going to practice a lot tomorrow, okay, this part, but I want us to make sure we go over this part before the end of class today, okay? So we were taking standard notation, writing it in scientific notation, but we also have to be able to undo that. We have to be able to go from scientific notation to standard notation, okay? Tanner, are we paying attention? Okay, so we're going to look at this bottom section. Are y'all with me?
What would it be 364?
Colby, are you awake? Okay. Okay, so let's look at number 11. So we have 3.64 times 10 to the 4th power. So first of all, I'm going to look at this exponent. This is how I do it. I look at this exponent. Is it a positive or negative? Positive. So is our ending number going to be a big or small number? A big number, okay? So what I'm going to do is I'm going to write this number down without the decimal in the front, because I know it's going to have numbers in the back if it's getting bigger. So 3, 6, 4 are the 3 numbers it gives us. Careful. Okay? Our decimal was right here. Okay? It was right here. And it says exponent of 4. So how many places did my decimal move to get there? 4. So we've got to undo those 4 movements. So I've got to go 1, 2. I'm out of numbers. So if I move 3, I got to put a 0. And if I move 4, I got to put another 0. Very good. Okay. I know an exponent of 4, some of us think, oh, I've got to add 4 zeros. Well, we don't, because this 6 and this 4 are 2 of our place values. We only need 2 because we only had 4 minus 2 here, left us with 2 zeros being needed. Sydney?
I already see number 14 has an exponent of 0.
You do? Okay, well, we're not there quite yet. Tanner?
I need to use that.
Okay, can you wait until I go over all this?
Sure. I'll try.
Are you writing this down? Okay, well, we need to be writing this down.
I can't see it right.
Okay. Again, you have the option of coming and sitting right next to me.
Yeah, but I can't write them.
I have a clipboard. Would you like to use it?
No, I have my glasses, so now.
Okay, then keep your glasses on.
Yeah, but they fall off my face.
Yes. Okay, I need to finish going over this. All right, let's look at number 16. I have 2.97 times 10 to the negative 4th power. Okay, so looking at my exponent first, it's a negative. So that lets me know this number is going to be
Move to the right.
It's going to be a small number, okay? It's going to be a small number. So if it's going to be a small number, that means I'm going to be moving my decimal to the left. So I'm going to put that 2, the 9, and the 7 on the back of the line. It's going to be a small number, so my decimal is going to move to the left. So I put it at the back of the line so I have space to move up front. Okay? This decimal was right here, and how many places do I have to move left? 4. 1. Now I've already run out of space, but I'm going to go ahead and go 2, 3, 4. Very good. 0 for that place, 0 for that place, 0 for that place. And the 2 counted as one of our spaces. And I can double count. 1, 2, 3, 4. And that decimal would have been 4 spaces. So I know I did this correct. Okay? Y'all can put a 0 out front if you want to. But y'all know I don't write any extra numbers that I don't have to. Sure. Okay. All right. Is there homework on the board? Okay then. All right, number 12, 3.9734 times 10 to the 5th power. Exponent, positive or negative? Positive. Number, big or small? Big. So where am I going to be moving my decimal to? The right. Okay, if I move it to the right, it's going to make this number big again. So 39734. My decimal was here, and I have to move it 5 spaces to the right. 1, 2, well, hang on. 1, 2, 3, 4, 5. Add 1 0. Add 1 0. That's it. All right, and Sydney wanted to talk about number 14. So before y'all pack up on me, 1 more minute, y'all. Okay? Technically, I have 3 more minutes, but you know. On number 14, we have 6.7978 times 10 to the 0 power. What's 10 to the 0 power is what? 1. Do y'all remember anything to the 0 power is? 1. Okay? Or how many places do we have to move our decimal? 0, because the exponent's 0. All right? Or so you can think about it 2 ways. The exponent's 0, we don't have to move our decimal any. 10 to the 0 power is 1, and what's this number times 1 going to give us? The exact same number. So it is 6.7978. That's it. Okay? Y'all do not have homework tonight, but I know. What I need y'all to do, though, okay, is make sure y'all don't forget scientific notation over the night, because I know how y'all are. Tomorrow, we're not listening if we're up and walking around. Tomorrow we're going to finish the back of these notes. So make sure you do not lose them, and then we're going to practice. Notice y'all do have homework over the weekend, so just be prepared for that.